we have given rational expression and we have to rewrite this expression into partial fractions. So first we have to check the power of numerator and denominator. In this example, in numerator we have t to first power, and in denominator we will have t to second power. So the power of numerator is less than power denominator. Everything is okay. And next, what we have here, we have denominator which is factorized, and now we see that we have t minus 3 is linear factor, and this linear factor repeats because we have t minus 3 to second power. So when we rewrite now our original fraction to partial fraction, when we have repeated linear denominator factor, we need to rewrite this denominator that this is t minus 3 to first power, we don't have to write, plus t minus 3 to second power. If you have here t minus 3 to sixth power, you will have t minus 3 to first power, which we don't write, t minus 3 to second power, to third power, to fourth power, to fifth power, and to sixth power. Because we have only t minus 3 to second power, so we finish at t minus 3 to second power. And now what will be in the numerator? In the numerator, because we have here repeated linear denominator factors, so we have only constant in the numerator, so it will be a and b. Now we have to find the constants a and b. First we have to get rid of the denominators. How we do this? We have to multiply both sides of our equation by the lowest common denominator. The lowest common denominator is always the denominator of the original fraction. So we multiply both sides by t minus 3 to second power. It means we have to multiply all expression in the brackets by t minus 3 to second power. So what will be now? T minus 3 to second power will reduce, and on the left side we will have only t minus 5, this is equal, and now every fraction in brackets we need to multiply by t minus 3 to second power. When we multiply first fraction by t minus 3 to second power, t minus 3 will reduce with square, and we will have only a times t minus 3 plus, and now when we multiply the second fraction by t minus 3 to second power, so this whole denominator will reduce, and we will have only b. So now left side we will copy, and now we have to do multiplication. A times t is a times negative 3 is negative 3a, and we have plus b. Now, because the left side must be equal to the right side, it means we have to check the coefficients. Before t, when we don't have number, it means this is invisible 1. So t, before t we have 1, and on the right side we have a. So a must be equal 1. And next we have negative 3a plus b, this is our constant, 3a plus b must be equal to negative 5. Why? Because the left side must be equal to the right side. Coefficients before t's must be equal, and constants must be equal. So we have two equations with two unknowns. A is equal 1 already, so now we have to just substitute to the second equation a by 1. So we will have negative 3 times 1 plus b is equal negative 5. So b is equal negative 5, and negative 3 times 1 is negative 3. We have to move to the other side, so it will be positive 3. So b is equal negative 2. So we found a and b. So now we have to come back to our partial fractions. We will rewrite our original fraction t minus 5 over t minus 3 to second power, but this is equal. A we substitute by 1, so we have 1 over t minus 3 plus b is negative 2 over t minus 3 to the second power. Positive and negative, so we can rewrite that this is equal. First fraction we will copy. Positive and negative, this is negative 2 over t minus 3 to second power. This is my solution.